Welcome. In this video we'll be solving trigonometric equations involving cosecant part 4. Let's take a look at our example. Solve the equation given below for theta greater than or equal to 0 and less than 2 pi. Here our equation is cosecant of 4 theta plus 7 pi over 6 is equal to 1. Now let's pay close attention to the input and let's define a new variable based on that particular input. So let alpha be equal to 4 theta plus 7 pi over 6. Now, the original equation can be rewritten as follows. Cosecant of the input, but in this case our input is alpha, is equal to 1. Rewriting this based on the definition of cosecant, we get the following equivalent equation. 1 over sine of alpha is equal to 1. Now, taking the reciprocal of both sides of this equation gives you the equivalent equation. Sine of alpha is equal to 1. Why is that the case? Well, the reciprocal of 1 over sine of alpha is sine of alpha, and the reciprocal of 1 is 1 over 1, which is still 1. Using that fact, we can say the following. We're looking for the angles alpha such that the coordinate of the point will have a y-coordinate equal to 1. To figure out what is the value or the values for alpha, all we need to do is to pay close attention to the unit circle. So let's go ahead and identify the point or points that will have a y-coordinate of 1. As you go around the unit circle, you realize that the only point that has a y-coordinate of 1 is this particular point. And the corresponding angle is pi over 2. So we say that here alpha has a value of pi over 2. But keep in mind, that's not the value from the original equation. So what we need to do is to solve for theta. So using the fact that alpha is equal to pi over 2, let's go ahead and solve for theta. So how do we do that? Well, keep in mind that alpha was defined to be 4 theta plus 7 pi over 6. And here we already have that alpha has a specific value. So let's go ahead and substitute this expression from the right hand side here into this particular spot. So we have 4 theta plus 7 pi over 6 is equal to pi over 2. Now our ultimate goal is to get the theta by itself. So let's go ahead and subtract the 7 pi over 6 from both sides of the equation. Thus you get that 4 theta is equal to pi over 2 minus 7 pi over 6. Now, let's go ahead and get a common denominator. To do so, let me multiply the pi over 2 by 1 in the form 3 over 3. So we get that 4 theta is equal to 3 times pi is 3 minus 7 times pi is negative 4. So we have negative 4 pi all over 6. Now let's divide by 4 on both sides to get the theta by itself. So notice here that the 4's cancel, and so do they do here. So we get that theta is equal to negative pi over 6. However, this particular value of theta is not on the interval from 0 to 2 pi. So what we need to do is to add the period of the original function to this particular value of theta. Now, the period of cosecant happens to be 2 pi. So we take that 2 pi and we're going to divide by the absolute value of the coefficient of theta. In this case, the coefficient of theta happened to be 4. So let's take the 2 pi, let's divide that by the absolute value of 4, and we get that this is 2 pi over 4, which after we divide both numerator and denominator by 2 becomes pi over 2. Why are we doing this? Well, because this is now the period for the new function that we had in here, which was cosecant of 4 pi plus 7 pi over 6. So the actual period of that function happens to be pi over 2. Hence, using that particular period, we take theta to be negative pi over 6 plus the period of pi over 2. So let's multiply this one by 3 over 3 to get the common denominator, and you have negative 1 plus 3 becomes positive 2, and then you have the pi divided by 6. Let's simplify this by dividing both numerator and denominator by 2, and you get that theta could be pi over 3. So that's your first value for theta. In order to get the next value for theta, we take pi over 3 and we divide the period of pi over 2. Now in this case, let's go ahead and multiply the first expression here by 2 over 2 to get the common denominator of 6, and this one by 3 over 3 to get the common denominator of 6. So you have 2 pi plus 3 pi becomes 5 pi all over 6. So that's the next value for theta. Now to get the next value for theta, we take the angle of 5 pi over 6 and let's add the period of pi over 2. Once again, let's multiply this one by 3 over 3 so we can get the common denominator, and we have 5 pi plus 3 pi becomes 8 pi, all of it over 6. Let's divide both numerator and denominator by 2, and we get that this is 4 pi all over 3. So that's your next angle. And then our next angle becomes theta is equal to 8 pi over 6 or 4 pi over 3. Let me just take the 8 pi over 6 here plus the pi over 2, which happened to be the period. So let me multiply this one by 3 over 3. And you get that this is 11 pi over 6. And these are your the 4 angles that will make that particular equation true. So therefore, we can conclude that theta could be pi over 3, 5 pi over 6, 4 pi over 3, or 11 pi over 6. And that concludes this video where we were solving trigonometric equations involving cosecant part 4. Thank you for watching and have a wonderful day.